In this video, we're going to be solving Leetcode question 200, which is number of islands. Let's get started. So in this question, we are given a grid, which is represented as a 2D array of elements, where each element is a string that either contains the value 1 or 0. So this is what the grid is going to look like right here. And this grid is supposed to represent a map, where the 1 values represent areas of land. So these are all areas of land on the map. And the 0 values are going to represent areas of water. So these areas are all contained with water. And we're also supposed to imagine that outside of this grid is also all surrounded by water. So like imagine this is all padded with zeros, so it would just be an entire ocean section around the grid, like this. Okay. And our goal in this problem is to count the total number of islands that are found in a grid. And an island is defined by a total area of land. So it contains all the ones that are connected to each other. And that area has to be surrounded by water. So in this particular grid example, there's actually only one island, which would be this one over here. So it's this entire landmass. It's connected. And it's also surrounded by ocean. So that's why it is an island. Okay, so let's think a little bit about how we can actually identify islands. First off, every single grid is guaranteed to have at least one island. And the reason why is because since the entire grid is said to be surrounded by ocean, there is at least one area of land that is entirely surrounded by water. There could be more, but there is at minimum one. So let's say we find a piece of land. Like let's say we go through the array and we find this element right here. That's obviously part of some island, but the question is, what are the other elements within that island? Well, an island is defined as all the connected pieces of land that are surrounded by water. So we need to find all of the other pieces of land that are connected to this exact one. In this case, it would be this piece of land over here, this piece of land over here, and you can get to this piece of land by going from here to here. So these 4 pieces of land are all part of the same island because you can walk to and from them, taking left, right, up, and downward steps. This piece of land is not connected to this island because there's no way to traverse from this point to here without passing some ocean. So therefore, this becomes a new island, which would be island 2. And these 2 are a third island, which would be your island 3. So in this particular grid example, there are 3 islands because there are 3 pieces of land which are separated from each other, meaning there's no way to get from one piece of land to the other piece of land without passing some ocean. So now the question is, once we find a piece of land, how do we find all the other pieces of land that are connected to that original piece? This is a classic searching problem, so we're going to use the searching algorithms to solve it. And like I've said in videos before, the main searching algorithms we can use are breadth first search and depth first search. They are almost always going to be the same time and space complexity, and usually you are going to decide which one to implement based on what is easier for the specific problem at hand. And I think again for this question, breadth first search is a little bit easier, so that's what we're going to be implementing. When we start from a piece of land, we're going to search in all 4 directions to find other pieces of land that are connected to it. So in this case, we have a piece of land here and a piece of land here, so that's added. And then from here, we do another search to all the neighboring pieces of land. So both these lands will converge at this point. So that's a 4th piece of land. And there's actually no other area because all of these are either already checked or zeros. So that means that's it. So that would be our entire breadth first search for that first island per se. Whenever we find a new element that has a new land element in our grid, we need to save that to some sort of hash set. So therefore, we don't accidentally search the same piece of land more than once. So once we discover these 4 pieces of land, this needs to be saved in some sort of set. And that way we don't accidentally go back to one of these pieces of land and double count. So here's the finalized solution algorithm for solving this question. We're first going to start with a nested loop that allows us to traverse through every single element in this 2D array. So it's going to traverse across and down and find every single element. Whenever we find a land element, the first land element we're going to find is the one in the top left. We're going to start a search from that element to find all of the neighboring pieces of land. And at this point, we would add 1 to our counter, which keeps track of the total number of islands. So we found 1 island so far, and we're going to search all around this area using a breadth first search like I described just before to find all the other pieces of land that are right next to it. And once we finish our search, this is the first island complete. All of these coordinates are now going to be saved to a hash set, so we know that we've already seen those pieces of land and we don't accidentally go back to those pieces of land. Then we're going to continue our search, and then the next element we're going to find is here. So because this has not been seen in our hash set before, this is a brand new piece of land we've never seen before, this is going to add to our island count. It can't be part of the same island as the previous element, so it has to be a new island. So now it's 2 islands right here. And again, we're going to do the same breadth first search, but this time there aren't any neighboring elements. These are all zeros. So this is just an island of size 1. And then last, we're going to continue doing this nested loop until we find another piece of land array that hasn't been seen before. So this is our third piece of land, which is going to be our third island. This can't be connected to the 2 islands we've seen previously. And once again, we do a breadth first search on this, and we find only 1 neighbor, which is over here, and that happens to be the end of our 2D array, so we're done. Therefore, there are 3 islands on this grid. This solution is going to take O of m times n, time complexity, and space complexity. And here, m represents the number of columns, and n represents the number of rows. So basically, we're going to have to go through each element of the array at least once, because we need to check that every single one of them isn't part of a new island or something. And we also need to save at most m times n of the elements, because we need to keep track of all the elements we've already seen, and specifically the elements that contain land. So in this example, we would have to contain 4 plus 1 plus 2, or 6 elements, but in general, we can expect to have to save m times n number of elements. So now that we have the algorithm and we know its complexity, we can start coding it up. If you're finding these videos helpful, I think you'll love what we got going on in our private community. We dive even deeper with exclusive content that won't be shared on the main YouTube channel. I also offer individualized coding interview study plans that are tailored just for you. You can also join small group sessions, participate in mock interviews, and get your questions answered in live weekly Q&As. It's a great way to take your coding interview prep to the next level. If you're interested, check the link in the description below. I'll see you inside. All right, so here is the Python solution for Leetcode question 200, which is number of islands. So first up, we're going to set up a hash set, and this hash set is used to keep track of all of the coordinates that we've already seen in our search. We also have another variable, which is num islands, and this is just going to count how many islands we've seen. So first I'm going to jump over here. We're doing a nested for loop to access each of the elements in our 2D array. And for each element, if that element is a piece of land, which means it's equal to 1, and the coordinates of that element are not already in our seen islands, we are going to increment our num islands counter, because this means we found a new island. If it is a piece of land and it's also not a piece of land we've already seen, this means it's a new island. And then we're going to start a land search on that piece of land. And let's go up to here. This is a recursive function that I wrote, which basically implements a breadth first search. So first we check that the home coordinate is not in seen islands, and if it isn't, we're going to add it to the seen islands. And then we are going to check the 4 areas around it. So this is checking I minus 1 would be to the left of it. So we first check that it is a valid index using this, and then we check that it's a piece of land using this, and then we start another land search when that piece of land is the home coordinate. And we do the same for the right neighbor, the bottom neighbor, and the top neighbor. And this is going to continue to discover new pieces of land and add it to seen islands until it doesn't anymore. And then it's all of them are going to return. And then we go back to this outer for loop and keep looking for islands. And this process is going to continue until this nested loop runs out. So that means we get to the bottom right of our grid. And that means we're done. We found all the possible islands in our array. So now let's run it. It passes our test cases. And if we click submit, it passes everything here as well. The memory score doesn't seem to be too good, but it seems to be very random. This is the optimal solution though in terms of time complexity and space complexity. So this is times rows times columns for time complexity and rows times columns for space complexity. So both are optimal.